I guess for those of you joining us online, good afternoon. My name is Diana Lee. I am the High Temperature Reactor Program Manager for DOE, and I'll be presenting scope for the RC-4 meetup call for high temperature gas reactors. I believe on the line with me we have Gerhard Stridham, who is our National Technical Director for high temperature gas reactors, and Paul Demkowitz, who is our TRISO Fuel Qualification Lead. And Gerhard will be acting as our technical point of contact for our RC 4.1 call, which I'll go into more detail on. And Paul will be the technical point of contact for RC 4.2. Before I go into the details of the scopes themselves, I wanted to give a little bit of background on our program. Our mission has been to reduce technical risks and barriers to high temperature gas reactor deployment. To meet that mission, we have been focused generally in 4 different areas. One is high temperature alloy characterization and codification. Just recently, after about 10+ years of DOE investment, we have been able to add alloy 617 to the American Society of Mechanical Engineers Code, Section 3 Div 5. And this is actually a very significant milestone because that is the first alloy or material added to that code for high temperature reactors in over 30 years. If you want to learn more about this effort, you can look on our NE website. And there's also a very nice article in Popular Mechanics on this. Another area that we have been focused on is graphite characterization and codification. And this part of our program has looked at many different grades of graphite to ensure that we characterize those grades of graphite and examine how they behave with respect to creep and irradiation, so that when developers want to use these grades of graphite, the data will be available for them to use towards their licensing efforts. A third area that we're focused on is TRISO fuel fabrication and qualification. This is another area that we have invested more than 10 years of effort. And in the last year or so, EPRI submitted a topical report to NRC using data from 2 of our experiments, the HTGR1 and HTGR2 experiments. And we expect any day now to hear back from NRC on a final approval of that topical report. And that topical report, when it's approved and accepted by NRC, should facilitate efforts by developers to use TRISO fuel in their reactor designs. And the final area that we have been focused on is computational methods and experimental validation. And this area is trying to primarily answer some open technical questions from the regulator on how the reactor responds in both normal operation and accident conditions. So for the next 2 slides, I'm going to go into a little more detail on our TRISO fuel program and our experimental methods and computational methods program, because those are the 2 areas that will be most pertinent to our calls for this year. This slide here shows our TRISO fuel qualification program timeline from starting around 2003, 2004. So as you can see, it's been a long time that we've been working on TRISO fuel. We started on a small scale, lab scale effort with our HTGR1 experiment just to show that we could fabricate TRISO fuel in a repeatable, methodical manner. Then we moved up to an engineering scale experiment with HTGR2, which also allowed us to compare how uranium oxycarbide and uranium dioxide fuel performed. Then we moved on to our HG3 and 4 experiment, which included design to fail fuel, because we wanted to use this experiment to give us a lot of data on fission product transport and use that towards source term determination. The design to fail fuel ensured that we would be able to see the fission products during the experiment. And finally, we had our HTGR 5, 6, 7 experiment, which has just finished irradiation at Idaho National Laboratory's Advanced Test Reactor. This experiment is meant to be our capstone experiment to provide the remaining bulk of data that we think we will need to support efforts to license TRISO fuel for use, and should also give us some data on fuel performance margins, as one of the capsules was designed to run at higher temperatures than what would normally be expected in a high temperature gas reactor. With respect to experimental validation and computational methods for our program, DOE has invested in several large integral effects test facilities in the past. One of these facilities is the high temperature test facility, which is a quarter scale high temperature gas reactor integral effects facility. And it has allowed us to examine how the reactor would respond in the event of a pressurized conduction cooldown event or depressurized conduction cooldown event. We also have at Argonne National Laboratory our Natural Convection Shutdown Heat Removal Test Facility, or NSTF. This is a half-scale model of a water-based reactor cavity cooling system, which allows us to simulate how passive heat removal would occur in the event of several different anomalies. For example, if there was a flow blockage in some of the risers in the reactor cavity cooling system. So while DOE has invested in some large-scale integral effects test facilities, we really also rely on projects such as from NEOP projects to provide complementary data through separate effects test facilities and maybe even integral effects test facilities to help us gain data to validate our methods computationally. On this slide, I just wanted to highlight some examples of high temperature gas reactor designs. From the pictures, you can see that some of these designs are very large, comparable to current light water reactors, while others are very small, micro reactors that can be transportable by rail. Our high temperature gas reactor program wants to benefit high temperature gas reactors no matter what size. So we primarily focus on cross-cutting areas that would benefit all of them. So this brings us to our scope for this year. So RC-4.1, this year we are looking for proposals to look into heat transfer characterization in horizontally oriented micro HTGRs. Heat transfer has been extensively examined in high temperature gas reactors in the past, but that was primarily for vertically oriented high temperature gas reactors. There are several developers now who are looking into horizontally oriented micro high temperature gas reactors, because that will allow them to have the reactor transportable by rail. And with that understanding, we would like to see proposals that will look into how that horizontal orientation would affect phenomena such as fluid flow, fluid velocity, where the peak fuel temperatures are over time, and what the effect is on establishing natural circulation in the event of a pressurized conduction cool-down event. For the proposals, we are seeking projects that could possibly determine the contribution of radiation versus convective heat transfer, and we will need all data to be accompanied with estimates of uncertainties. Proposals that will take into consideration United States-based high temperature gas reactor designs will be considered higher relevancy for our mission. And projects that will use standard 14th brain MHTGR 350 fuel block designs with helium will be considered higher priority. If you want more details on the scope, you can look into the actual written details on our funding opportunity. Also, I want to mention again, for this scope, Gerhard Stratum is our technical point of contact. One other item I should note is that on the schedule for the NEOP webinar, the RC-4.1 description is different because we actually changed the scope. So I think it currently says that it's focused on near wall effects for pebble bed reactors, but we have changed the scope. So this year we are focused on, as I said, heat transfer characterization for horizontally oriented micro high temperature gas reactors. Moving on to RC-4.2, this year we are seeking proposals on high temperature gas reactor fission product source terms. As I mentioned before, our advanced gas reactor program for TRISO fuel has been working to gather data on fission product transport, but that has mostly been focused on TRISO fuel itself. And this year we would like to see proposals on how fission products behave in reactor coolant systems. We haven't looked into this phenomenon in the past because it's highly dependent on the reactor design. So phenomena such as fission product plate out, lift off, wash off, and vaporization all affect what the fission product release could be from a reactor accident. For proposals, we are looking for projects that will use appropriate scaling factors, consider design basis accident scenarios that have significant impact on radionuclide transport, and those proposals that will use the latest industry design information will be considered higher priority and relevancy. So moving on, these are requirements for both RC-4.1 and RC-4.2. All experiments must be performed to NQA1 standards, and any data, descriptions of experiments, and calculations will have to be submitted to our Nuclear Data Management and Analysis System, NDMAS. For projects that are eventually awarded, if the PI is not familiar with our NDMAS system or the NQA1 requirements, you may be able to get assistance from Idaho National Laboratory to ensure that your NQA1 program is properly established and to send your data to the NDMAS system. So again, I want to state for RC-4.1, our technical point of contact is Gerhard Stratum, and for RC-4.2 on source term determination, our technical point of contact is Paul Demkowitz. And with that, that's all I have. I guess if there's any questions, we can take them. Thank you very much.
Diana, thank you for the clarification on the focus of the RC-4.1. That was an oversight on my part. We will take questions over the next few moments. Please submit those in the question box of the GoToWebinar. We'll keep Diana and Paul and Gerhard here for about 5 minutes. While we're waiting, let me unmute Gerhard. Can you say something? I just want to make sure we can hear you.
Can you hear me, Drew?
Yes. Yep, you're coming through.
Yes,
Let me also unmute Paul. Paul, are you there?
This is Paul. I'm here.
Hi, Paul. All right, we'll just hang on for a few minutes and wait for questions to come in. Thank you. Okay, one final reminder to submit your questions. We'll hang on for about 1 more minute. Okay, we have our first question. Do you consider NEAMS simulation tools such as moose-based animals for HTGRs for simulation research?
I guess, Gerhard, maybe
one.
I'll defer to you.
Right, go ahead, Ina.
Oh, I was going to say I would defer to you, but I mean, NEAMS toolkit of simulations is always welcome as far as I'm concerned.
Yes, same from my side. I think it's it's at this point a DOE directive that we should encourage use of these tools. So if at all possible, that would be our preference indeed.
What would be the source of data for the circulating activity phenomenons?
Yes, Paul, can I defer to you on this question?
Yes, this is Paul. Would you please repeat that question?
What would be the source of data for the circulating activity phenomena?
So yeah, so we can make certain AGR data available, and I think again the source, the reactor source term is going to be very design dependent. So there's going to have to be a lot or some assumptions on reactor design to come up with total circulating source term. But in part, that's I think that's part of the intent of the call as well. It is focused on behavior in the within the pressure boundary, but it's also going to look at source term from the core as well. Gerhard, do you have any other thoughts on that?
Paul, I think that's quite correct. It is design dependent, and we can assume some generic design maybe for our analysis and provide a source term as input then for a representative design. Put it like that. So I think that should be fine. Yeah.
Yeah, and I mentioned the AGR data. That's not going to be something in terms of giving a specific source term for a specific design. It's more it could help guide assumptions on the fraction of release of different fission products from the core depending on temperature.
Correct.
Are there any particular reports that are worth looking at to learn of specific horizontal thermal hydraulic issues in HTGRs?
As far as I know, this is a relatively fresh area. The reactor designers out there that's playing with this orientation is kind of blazing a little bit of their own trail. So my guess would be, as far as I'm aware, there's not much to be found in the open literature. Most of these projects are tied down under IP. So, the idea would be to take a small experimental setup, I guess, and flip it around horizontally and see what changes. But apart from that, there is not much data out there.
All right, so for both scopes, we highly encourage you to communicate and reach out to the vendors that are developing these designs that you might be modeling your experiment on.
What advances beyond currently published research is really required for near wall heat transfer?
We're not going to be looking at near wall heat transfer. That was a scope that we had originally planned, but we are actually going to be focused on the two I mentioned here, one for horizontally oriented high temperature gas reactors, and one to determine source term behavior.
What radionuclides would be of interest? Are we supposed to examine a number of them in the experiments or perhaps focus on a limited set?
I think we can leave that to your proposal, but if you look at the available data and reports, you can see what fission products have been focused for example, the HTGR program. And we will be looking at the details in your proposal to see if what you plan to examine makes sense reasonably.
Are you interested in fission product migration or diffusion in structural graphite?
I think, Paul,
This
maybe
is
I'll
Paul.
defer to you on that.
Yeah. I would say no. So that has been the subject actually of some calls in past years. I forget if it was 2 or 3 years ago. So yeah, this is really focused more on the behavior of circulating activity.
On fission product transport and the cooling system of HTGRs, is modeling and simulation of interest, or only experiments, or both?
This is Paul. I would say both. Is that consistent with what you were thinking, Diana?
Right, yes. I mean, I think definitely we want some experimental aspect, but if there is modeling, we welcome that as well.
Yeah, I think the key, consistent with most of our past calls in this area is that we'd like the focus to be on experiments, simply because it's not as of interest to have a purely theoretical mod and sim type project. I would like to have it backed up with some experimental data because there is a lack of that.
Is decay heat removal in horizontal microreactor prismatic designs primarily through an RCCS?
I think, again, that design detail is probably tied down under IP for the various HTGR designers. So I would not necessarily assume such a specific system, but obviously some kind of a heat removal system on the outside of the vessel. So it can be pretty generic at this point. We're more interested in how the heat moves within the vessel component as opposed to outside the vessel at this point.
Are DOE facilities available for liftoff and plate out experimentations?
I don't believe that was part of the plan for this call. It's not generally, that would have to be something that a PI would pursue separately, possibly through something like NSUF, but that's not something that we plan for this call.
Yeah, I agree.
I am assuming the main objective for RC 4.1 is to get experimental heat transfer data for horizontal micro HTGRs?
That is correct. We are more focused in that case on experimental work than simulation work. But of course, it's always advisable that you do check results, if possible, with either CFD or the new NEAMS tools, if possible at all.
For RC 4.2, is the main focus on producing generic experimental data and modeling to produce source term behavior?
Yeah, I think that's a good way to summarize it.
Do you know which US-based HTGR designers are considering a horizontal HTGR?
We did include 2 references in our written up call there of public available websites, for example. So you're welcome to take a look at that.
There's also a clarification provided by Madeline Feltis here at DOE on the source of the data, on the fission product data. It would come from historical tests, and there are references given in the solicitation. We'll hold on for a minute or two longer for any additional questions. Okay, I think those are all the questions we have. Thank you, Diana, Gerhard, and Paul for joining us. We will return at 4 o'clock Eastern time. Thank you for your patience with these long breaks. We plan these for any potential equipment malfunctions or other such things. So we appreciate your patience, and we will be back with you at 2 p.m. Mountain, 4 p.m. Eastern. Thanks.
Great, thank you.